Hello and welcome to Aditya classes. Today we'll take up a question on transportation and we'll try to solve it using WAM. So we'll find out IBFS using WAM and then we'll try to optimize it using both the two methods that we know, that we have studied, modified distribution and stepping stone. So the idea is that we need to optimize this transportation problem using modified distribution and using stepping stone, whereby we'll be starting our question, that is we'll be finding out our IBFS using WAM, that is Vogel's approximation method. And then the second scenario is if the load at second is changed to 45, then find the optimum solution. So the load at second workstation or whatever we are calling it, if this changes to 45, then we need to find the optimum solution once again, because then it will become an unbalanced problem. For now, if we see it as 20 and 25 45, 10 and 15 25 and 20 45. So it is a balanced problem right now. But if it becomes an unbalanced problem by making this as 45, then what will be the optimum solution? So we'll go ahead and solve this using WAM and then optimize it using modified distribution and stepping stone, both methods. So first of all, let us find out our IBFS. Now when we are solving this question, I assume that we have a basic knowledge. We have seen our earlier videos on transportation and WAM and optimization, so that here we can straight away go and make assignments. So we have our first and second source station, we have A, B and C destinations, then distances are given as 9, 8, 7, 6, 10 and 8 between them. They have a capacity to supply 20 and 25, there is a demand of 10, 15 and 20. Now we need to solve it using modified distribution. So first, Vogel's approximation method. So first thing would be to find out their penalties, because we are making use of Vogel's approximation method. So penalties for rows are the difference of least 2. Least is 7, next least is 9. Difference of 9 and 7 would be 2. Difference of 6 and 8, or you can take difference of 6 and 8, it will be 2. Then difference, column wise also we need to find out penalties. 8 and 9, difference giving me 1, 6 and 7 having a difference of 1, 8 and 10 having a difference of 2. So from these penalties we select the highest penalty. Now in this case, okay, one is small, but then there are 3 cases where we have a penalty of 2. So which one should we opt for? You can go for either of these penalties. There is no harm, because when we are studying these techniques in operation research like transportation, assignment, simplex, these are iterative processes. They go on iterating the problem until we reach the best problem. Now there will be ties, there will be situations where you could go left or right, where you could select first, second or third penalty. You could select any. Depending on your choice, it might so happen that the number of iterations increase. It might so happen that if I make a perfect choice, I get my answer in first iteration, or I get my answer in least number of iterations. And if I make a wrong choice, if I go somewhere wrong, no worry at all, because the process, these algorithms are such that they'll optimize upon them. Even if you make some mistake over here, as long as you are sticking with the algorithm, you will reach the ultimate point, optimum point. So what we'll do is, we can take either of these two, but we'll check which of these twos has a capacity to transfer most of my units. For example, if I select this 2, if I select the penalty of this 2, then source 1 is selected. What is the least distance in source 1? That will be selected. What I am doing is I am trying to minimize the penalty, minimize the cost, minimize the losses. So I am giving these penalties a chance so that I do not face these penalties. So if I select this 2 means I am selecting source 1. Source 1 has the best option in 7. Because this is 9 and 10, these are more distances, these are greater distances as compared to 7. So 7 is the best choice for this 2 or source 1. So if 7 is the best choice, then what is the amount of units that can be transported in this 7? There is a supply of 20, there is a demand of 15. So I can transport 15 units, 15 units in this cell. If this 2 is selected, I'll be able to minimize, I'll be able to defend my costs on 15 units. I'll be able to defend this penalty of 2 rupees on 15 units. I'll be able to save 30 rupees. because penalty is we are trying to save. Now, this penalty, if I take this to or second source, this is the best option. If I take this 6, there is a supply of 25, there is a demand of 15. So either ways, if I take this 2 or this 2, either of these two will give me a supply of 15. A supply of 15 means I am saving a penalty of 15 multiplied by 2, 30 in either of these cases. So both are equally good for me. Let me check this 2. If I take this 2, there is the destination C. Let us call these sources and destinations. Source, destination. Now, if I select the third one, that is this 2. If I pick this 2, then I am selecting source C. For source C, the minimum distance happens at 8, and 8 has a supply of 25 and a demand of 20. So it can transport 20 units. So what I'll do, I'll take 20 units. Because these twos have a capacity of transferring 15 units for me, but this 2 is giving me a transfer of 20 units. I am able to transport 20 units. I am able to save a penalty of 2 rupees on 20 units. I am able to save a penalty of 40 rupees, which is a good amount, which is a better amount than 30. So I'll go with this. Now, next we need to update 25 and 20. This destination is exhausted. This 20 have been supplied. So there is a deficit of 5. Of these 25, 20 have been supplied. Now I need to supply 5 more. Okay, first stage is through. Now let me find out the penalties once again. Now row penalty for first source would be difference of 7 and 9 giving me a row penalty of 2, difference of 6 and 8 again giving me a penalty of 2, difference of 9 and 8 giving me a penalty of 1 and a penalty of 1. As far as this is concerned, this is done from this point on. Fine. So 1 and 1 we can reject because we already have higher penalties of 2 and 2. These 2's we have checked. If you go with this 7, it will cost you a penalty of 15. If you go with this 2, it will cost you a penalty of 15. You can go with either. Let us go with smaller distance, smaller cost. So we can transfer. Oh, sorry, it is not the same. If I take this 2, it means I will be selecting this 6. This 6 can transfer 15 and 5. A supply of 5, a demand of 15. This 6 can transfer only 5 units. While if I take this 2, it will go to source 1. Source 1 has 7 as best option. This 7 can transfer me 20 and 15. It can transfer me 15 units. So yes, in previous tab, both these 2's had a capacity to transfer 15 units. But this time, this 2 can transfer 15 units for me, but this 2 can only transfer 5 units for me. So I'll go with the first 2. And I'll assign 15 units here. With this assignment of 15, what happens? A destination is exhausted. Of these 20, 15 have been supplied. And now there is only one destination and both sources have a total supply of 5 and 5. So we can just go ahead and assign them straight away. Because now there is no choice. You have to get these 5 from here, you have to get these 5 from here to make your 10. So now there is no choice. This is my IBFS using Vogel's approximation method. What is the cost in this case? If you see, total cost would be 9 multiplied by 5 plus 8 multiplied by 5 plus 15 multiplied by 7 plus 20 multiplied by 8, making it 45 plus 40 plus 15 sevens are 105 plus 160. So we get 150 and 200, making it 350. So total cost in my first iteration is 350. This is the total cost that I'll be facing as this allocation in IBFS using VAM, Vogel's approximation method. Now let me check it using modified distribution and then we'll check using stepping stone. So what we'll do is we'll create a partition over here. This is my IBFS. This is IBFS using WAM. Now let me go ahead and check for modified distribution. In order to proceed to modified distribution, we need to check if my number of assignments is equal to m plus n minus 1. M plus n minus 1 is number of rows plus number of columns minus 1. Number of rows are 2. Number of columns are 3 minus 1. 3 plus 2 minus 1, that is 5 minus 1, that is 4. How many assignments do I have? 1, 2, 3 and 4. So yes, my condition to move to modified distribution is fulfilled, satisfied. I can move to modified distribution. Let me go ahead and use modified distribution. How do we use modified distribution? We transfer the costs of all the assigned cells. Assigned cells, costs, not the assignments, costs. In this case, distances. Distances of assigned cells. We have a 9, 8, 7 and 8. This is not there. So my assigned cells are 9, 8, 7 and 8. 9, 8, 7 and 8. Next is we put either of all the U's and V's. These are U1, U2, these are V1, V2, V3. Now I assume that you have seen our previous lectures, previous videos where we have talked about Vogel's approximation method, modified distribution, stepping stone in detail. So I'll assume that thing, that you know the process. So these are U1, U2, V1, V2, V3. We can take any of these as 0. Let me put this one as 0. If I put this as 0, now U1 plus V1, U1 is coming in, V1 is coming in, they are intersecting at this point. U plus V should give me value of A. U1 plus V1 should give me value of Ui plus Vj should give me value of Aij. U1 plus V1 should give me A11, this value. So what is U? 0. V I am not sure. A definitely I know 9. So V is equal to 9. So if this is 0, this becomes 9. Now something, we need to put something over here so that when we add them, it becomes 7. It will be 7. Fine. Then we need to put something over here which we add. If we add, it should become 8. So it will be 8 minus 9, that is minus 1. We can always decide as inside minus outside. 8 minus 9. Here we had 9 minus 0, 9. 7 minus 0, 7. This time we have 8 minus 9, minus 1. Inside minus outside. Inside minus outside. 8 minus minus 1, 9. Let me check. 9 and minus 1 added, they become 8. Perfect. So this is our first step in modified distribution. Then what we do? We go ahead and find the remaining cells. What is happening? U and V are added to get the cell value. U and V are added to get the cell value. So here U and V added would give me a cell value of 9. U and V added would give me a cell value of 6. Fine. So I have a 9, I have a 6. Then original cost minus this newfound cost. 6 minus 6. 6 minus 6 gives me a 0. 10 minus 9 gives me a 1. As we have these as 0 or positive, hence it indicates that this solution is optimum solution or best solution. If there were any negative values, then yes, I would have gone forward and optimized the problem. But for now, this is the best solution. This is the best cost. So this was our optimum solution using WAM and modified distribution. But we have a second question also. This is our solution to problem A. Then we have a second question also that use WAM to find IBFS and optimize using stepping stone. This time we'll be optimizing it using stepping stone. So we'll start with stepping stone over here. How do we proceed with stepping stone? Let me pull this question over here. Let me pull these assignments also, and then we'll see. With assignments of 5, 5, 15 and 20. So we have this problem, we have these assignments taken from WAM. So assuming that we have solved our problem using WAM, now we'll try to check this assignment using stepping stone method. Now what is stepping stone method? That the unassigned cells, what we are doing over here is that I have my IBFS, I have my possible best solution is here. Now I'm exploring that I've left this cell empty, I've left this cell vacant, first and second, A, B and C. I've left cell first C vacant. What if I put some load over here? What if I make some transfers from other places and put something over here? If I put something over here, what will be my situation? Will I be better off or worse off? This is what I wish to check. What if I put something over here? Because right now I'm transporting cells with values of 9, 8, 7, 8. So this 6 looks like being attractive. When you are transporting using distances of 9, 8, 7, 8, 6 is definitely better. Let me explore it. So what stepping stone does is, it will explore all the unassigned cells. So let me start with cell first C. Cell first C. If I make an assignment in this cell first C, I'll be putting up some units over here. So I'll be adding some units over here. Now, if you wish to add some units over here, you need to subtract some units from this row. Otherwise, this will exceed the allowed capacity 20 and 25, 10, 15 and 20. So if you put something here blindly, then it will go above 20. So I need to reduce something from somewhere. So the idea is we need to find a closed loop starting from this point, making horizontal and vertical movements just like we do in further optimization in modified distribution like we have learned. Same we'll be doing over here. If I add something, if I take this, what is this? This is an assigned cell. This is an assigned cell. This is an assigned cell. And this is also an assigned cell. Now what I want is, I want to add something over here. You need to find a closed loop. And these are your stepping stones. In a pond, these are stepping stones. From this point, you need to reach this point in a pond. Then you step over these stones. You can go here, here, and out. Or you could take this path, this path, this path, this path. You could take any of these paths. So there are options. Idea is these are stepping stones and you need to land on them only. In this case, if I start my journey over here, I have these 1, 2, 3, 4 stepping stones in my pond. I need to go, take a round and come back home. From this plus, I can come to this minus. From here, I can jump here. But yes, remember, I need alternate horizontal and vertical. You need to make alternate horizontal and vertical moves. So if I make a move over here, this is horizontal. Now there is no option for a vertical jump. So this is not a good idea to move. From this, if I take a jump over here, this is a horizontal. Can I come here? This is a vertical. From this vertical, can I make a move here? This is horizontal. And from here, I'll be back home. So this is the idea. You need to prepare a loop. So how can I prepare a loop over here? If we look closely, we have a plus, here we can see minus, plus, minus, and yes, wherever you are jumping, you are putting a foot, you will put a sign, and those signs will also be alternately plus and minus. We'll start with the plus. First sign will always be a plus from where I'm starting my journey. There's a plus, then alternately wherever you are stopping, you are putting a foot on this stone, put a minus. Then you are putting your step on this stone, put a plus. Next stone, minus, plus, minus, plus, minus. This is the idea of stepping stone, that we are stepping on these stones in a pond to make a loop, to go around the pond and come back home. So what is the value of cell 1C? If I try to explore what is the potential of cell 1C, the potential would be an increase of 10 rupees per unit. If I put a unit over here, I'll have to pay 10 rupees. In this case, it'll add 10 kilometers. Rupees are easier, so I'll call it cost only. Otherwise, it is distance. So putting a step over here increases my cost, increases my distance by 10. But then this decreases my cost by 9. This increases it by 8 and this decreases it by 8. 10, this is value is 9, cost, or in this case distance, plus 10 minus 9, plus 8 minus 8, giving me a potential of 10 and 8, 18, minus 17. An increase of 1 rupee or 1 kilometer in this case is expected if you try to put something over here. Right now this cell is vacant. If you try to add something over here, it will increase your cost by 1. So it doesn't look like being a lucrative proposition. It is not a logical proposition. So I reject this 10. Now what do I do? There is another vacant cell. Where is that vacant cell? That vacant cell is in second B. If I put a plus over here, can I jump to this point? This will be too small. This is a stone, this is a stone, another stone, and finally another stone. If I start my journey from here, a horizontal move, then there is no vertical option. So this is not suggested. Wrong idea. A horizontal move, a vertical move, a horizontal move, and back home. Other way around, you could have taken a vertical move, a horizontal move, a vertical move, and a horizontal move. So either ways you can travel, and this will be my loop to come back home. What is the cell? The cell is second B. So can we have cell second B? What is the potential for cell second B? What will be my loop? The loop that I have identified is plus, minus, plus and minus, thereby giving me a total cost of 6 minus 8 plus 9 minus 7 plus 6 minus 8 plus 9 minus 7, making it 15 minus 15 or 0. Now it is 0, so it will be a no change. The cost will not change. The distance will not change. It will still remain 350 only, because this cell has no potential. Neither it is increasing nor it is decreasing. This cell will increase. If you put 1 unit over here, this distance will become 351. If you put 10 units over here, this distance will become 360. So this is what we mean by potential. Now if we check these two, modified distribution, and this is our second method, that is stepping stone. Cell 1C is having a potential of increasing 1. Cell 1C is having a potential of increasing by 1. Cell 2B is having a potential of 0. It will not change. Cell 2B, potential of 0. So either technique we can make use of, that is modified distribution or stepping stone. You can make use of either of these techniques. Both are pointing to same answer, same solution. That is, that this is the best possible value that you can have. So this was our use WAM to find modified distribution and stepping stone. Next bit is if load at second changes to 45, then again find out optimum solution using both these techniques. So let us go ahead and remove this and then we'll solve this question using a load of 45 over here. Fine, so I'll remove it and we'll continue. So here is the second bit. If the load at second changes to 45, if the load at second changes to 45, then what do we do with it? Now if I add the loads, I see that I have a load of 65 and a supply of 65 and a demand of 25, 45. So there is a deficit of 20. When I am adding the columns, there is a deficit of 20. It is only adding up to 45 while rows are adding up to 65. I need more columns so that I can supply these 20 additional units. So what we do in such cases, we add a dummy row or dummy column. We'll add a dummy column because the columns are falling short by 20. So we'll add a dummy column. Fine. And this dummy column will have a load of 20. 20 and 45, 65, 40 and 25, 65. Now it is balanced. Now I can go ahead and solve it using WAM. So let us go ahead and solve it using WAM. Difference of least to 0 and 7, a penalty of 7. 0 and 6, a penalty of 6. A penalty of 1, a penalty of 1, penalty of 2 and a penalty of 0. So we select the highest, largest penalty which is at 7. At 7, we have source 1. We have source and destination. At 7, we have source 1, least cost cell is 0 kilometers. It can transfer me a load of 20. Now what this 20 has done, this 20 has exhausted first source and my dummy destination. This was dummy destination. This has been exhausted. 20 supplied, 20 received. Done. Now if I look at single row, whenever we have a single source or single destination, we can check it. It will be balanced and you can supply all the units straight away. Now if we have a supply of 45 and we have a demand of 45. So we can straight away go ahead and make these supplies. Done. Next, we need to proceed to modified distribution. In order to proceed to modified distribution, we need to check the condition that number of assignments should be equal to m plus n minus 1. Number of rows 1 and 2. Number of columns 1, 2, 3 and 4 minus 1, making it 4 into 6 and 1. 6 minus 1 is 5. How many assignments do we have? 1, 2, 3 and 4. These should have been equal. Number of assignments should be equal to m plus n minus 1. But this time I am not having m plus n minus 1 as equal. This is a state of degeneracy. This is a state of degeneracy. The solution is degenerate right now. What is a state of degeneracy in various algorithms of operation research? A state of degeneracy is where an optimum solution is possible, but we do not have a passage to that possible optimum solution. We do not have a way in which we can proceed towards that optimum solution. It is possible, but I cannot proceed. It may be possible. It is not. It may be possible, but I have no idea. I have no way to check if optimum is possible or if this is optimum. In simplex also degeneracy means this only, that an optimum solution may be possible. I have no idea how to check it. Here also optimum may be possible. I have no idea how to check it. So how do we solve this degeneracy? Check the unassigned cells. How do we take care of this degeneracy? Check the unassigned cells and select the least cost independent cell. How do we take care of degeneracy? By selecting least cost independent cell. This is how we can solve our degeneracy. Select a least cost independent cell and put a very small value epsilon. Epsilon, a very small value, almost equal to 0. Infinitesimally small value, almost equal to 0. So practically it will do nothing, but theoretically it will remove this inequality. Practically it is 0. If I put a 0 over here, 7 into 0 is 0. If I am saying that transport 0 units from first B, it is 0. But theoretically it will break my inequality. So I'll put an epsilon in least cost independent cell. Least cost is, we'll start with the least possible costs and check if those are independent. What do we mean by independent? Independent is that a closed loop should not be possible. When we are trying to optimize them, we look for closed loops. In stepping stone, we look for closed loops. Here we'll see the opposite. The closed loop should not be possible. Suppose least cost is 0. If I select this 0, I can make a vertical move, but then there is no horizontal move. Not a good idea. If I take this horizontal move, no vertical move is possible. I need to make alternate horizontal and vertical moves as we checked for a loop. If I make a horizontal move over here, jump over this, directly come here, no vertical possible, no vertical possible. So this 0 looks to be a very good proposition. What I'll do? This is an independent cell. There may be more independent cells, but this is the least cost independent cell. Let me check 9. Is this independent? 9 to 20, but then vertical movement was not possible. Now I have epsilon, but before putting this epsilon, if I had checked this 7, I can go from 7 to 15, I can go from 15 to 20, but then vertical is not possible. I can go from 7 to 15, 15 to 8, no vertical possible. So this 7 was also independent. So we need to just pick a least cost independent cell. This is least cost, it also happens to be independent, fine. We'll take this, we'll put an assignment of epsilon. Now what has happened? Now I have 1, 2, 3, 4 and 5 assignments. So what we can do is, now we can get rid of this inequality because I have 5 assignments. And yes, now I can proceed to modified distribution. How do we proceed to modified distribution? We transfer the costs of assigned cells and then proceed with UV. This method is also known as UV method. UV method, modified distribution. Now what we do is transfer the costs of assigned cells, 8 kilometers, 6 kilometers, 8 kilometers and 0. And then there is a 0 over here also. These are the assigned cells. You can put any U or V as 0. If you have seen previous videos, we preferably select a U or a V with maximum assignments. If we see this U2 has 4 assignments, let me pick this 0. Let me pick this U. 0. What this does is, it gives me these values straightforward. 8, 6, 8 and 0 because this is 0. 0 plus 8 is 8. 0 plus this 6. 0 plus 6 is 6. 0 plus this 8 is 8. So we preferably select a 0 in either a U or V having maximum number of assignments. We see 5 values are solved. And what about here? It will be a 0 because 0 plus 0 would give me a 0. So these are U's and V's. Next, we need to check, fill in these values. 0 plus 8 would give me an 8. 0 plus 6 would give me a 6. 0 plus 8 would give me an 8. Fine. And then subtract these new cell values from original cell values. 9 minus 9 minus this new value 8, 1. 7 minus 6, 1. 10 minus 8, 2. So this tells me that the solution that I have is optimum. This is the best possible solution that you can get. What was the total cost? Sorry, we missed the total cost over here. Total cost over here is 80 plus 90 plus 160 plus 0 plus again a 0. The total cost is 16 and 9, 25, 330. This is my total cost. This total cost is the best total cost because this is suggesting me. What we did in modified distribution, we transferred 8680 and 0 over here. We took this as 0, we had 868 and 0. This 0 got me here, 0. We filled in the cell values 868, then we subtracted these from original values. 9 minus 8 would be a 1, 7 minus 6 would be a 1, 10 minus 8 would be a 2. So all these cell values are positive, hence they are increasing the total cost. So I am not selecting any one of these. This was using WAM when load is 45 using modified distribution. Using WAM as IBFS, modified distribution. Now let us have a very quick look for stepping stone. Let me put total cost over here. Total cost is 330. Total cost in this case it becomes total distance. It is not total cost, rather it is total distance. For stepping stone, what we do is nine 8 7 6 10 8 0 and 0. Then there is 20 10 15 20. Then there is a 20 45 10 15 20 20. Now for stepping stone, we need to find out potential of each unassigned cell. We have A, B, C and dummy. So what are the cells that we have? Unassigned cells. We have first A, we have first B, then there is first C, and then there is second dummy. Let me calculate potentials for all. If I start my journey from here, can I trace a closed loop? I can come here, I can go here. Okay, there was an epsilon over here. I can come here, jump here, jump here. So first A would make a plus, minus, plus and minus, making it 1. 1B this, plus, minus, we can have this loop, fine. So it will be 7 minus 6 plus minus, I am not putting all those values over here, I am solving it directly because we have seen in the earlier case also. Then for this you can take this loop, plus, minus, making it an increase of 2. Second dummy was assigned. We made a dummy assignment, an epsilon, an infinitesimally small assignment in order to resolve degeneracy. We had a degeneracy in this question. So this was epsilon. So first A will be increasing a cost, increasing the total cost by 1. First B will be increasing cost by 1. If I put something over here, if I put some load over here, if I put some assignment over here, this will be increasing by 2. Let me check what modified distribution was telling. Increase of 1, increase of 1 and increase of 2. So you can use either of these techniques. Both will yield you same results. Modified distribution and stepping stone. So this was a transportation question where we had degeneracy. Degeneracy is a situation where a better solution may be possible, but when given resources, I am not able to go there. I am not able to move to my optimum solution. So this was it for our today's discussion. Until we meet next time, do take care. Thanks for watching. Bye-bye.